We got a 5.5 here today. We're going to be talking about the double angle and half angle identities. So these are kind of useful if you have an angle that is 2 times something that you already kind of know. Now, a lot of times these double angle identity problems are not actually going to do, like, if you had, like, for example, if you're trying to find, like, sine of 60 degrees, theoretically, you can use this formula and say, hey, that would be the same thing as 2 times sine of 30, and then cosine of 30 degrees. And we really could just do sine of 30 or sine of 60 degrees without using this little formula. So a lot of times when they're doing these little formulas, they're actually going to be doing the ones where they give us a triangle and we're going to have to, like, sketch that triangle into the correct quadrant. So that's how that's going to work 99% of the times on these here. So let me show you this here in action. We'll do a couple of these. So we got if sine of theta is negative 7 over 25, and then it's on the interval from pi to 3 pi over 2. That's going to be in that bottom left quadrant. So I'm going to go ahead and start sketching that out. Remember, you're going to always make an angle with the positive x-axis here, so this will have the opposite side being 7, the hypotenuse being 25, and to get the signs match up, we'll make sure that's negative 7 right there. And then once you do Pythagorean theorem, it does come out to where you have negative 24 right there for that side, and that's just, Pythagorean theorem. We're going to assume you can do that there pretty quick. So now that we have our angle, I'll label it here theta to help myself kind of keep this organized. And now the instructions say find sine of 2 theta, cosine of 2 times theta, and then tangent of 2 times theta. So let's color code this here. I'll do the first one here in red. And these formulas, typically we're going to provide them to you, so you don't necessarily need to memorize them. You just need to know how to apply them here. So sine of 2 theta, I'm just going to rewrite it here. It's 2 times sine of theta, which we're going to use our triangle to go and figure out. And then we'll do cosine of theta, which we'll also use our triangle to figure out. So you'll do 2 sine of theta. I'm going to go look here. Sine is always the opposite over the hypotenuse. So that'll be your fraction negative 7 for 25. Cosine of theta is going to be the adjacent over the hypotenuse. So that'll be negative 24 over 25. And then you're just going to multiply all of that together. When you're multiplying fractions, you can keep that 2 as 2 over 1, and then 2 times negative 7 times negative 24, and then you'll do the 25 times 25 down in the denominator. According to my notes here, we're going to get the double negatives will cancel out, so this will be positive 300, and I think my notes say here 36, a little small, and then 625 right there. You just get that from multiplying straight up in your calculator. So pretty straightforward there on that. All right, next we'll do cosine. I'll do this one here in purple. Now the cosine formula, there's 3 variations here to it, so you can pick one of these here. You don't have to do all 3 of them here, so I think I'm just going to pick, like, I don't want to deal with cosine and sine, so I'm going to just pick this second one right here, but you can technically do any variation of it. So I'll write that down here. Really, probably not even necessary to actually rewrite it again. So now what we're basically saying is I need 2 times your cosine fraction, and then we are going to square that fraction, whatever it is, and then we'll need to get a common denominator and eventually subtract off 1 right there. So cosine, let's go back and look at that. That would be negative 24 over 25. All right, that's the adjacent over the hypotenuse to your angle right there. Okay, and then honestly, if it's on a calculator section, I would just type it into your calculator because I don't have those numbers there in front of me. So, anyways, if you didn't have a calculator, you'd square it. Make sure if you square something that's negative, it becomes positive, and then you'd get a common denominator with that. That apparently is going to come out to 527, and then over 625. That'll be your answer there. So just go ahead and just straight up type it into the calculator, and that should be good there on that. Okay, and then finally we can go do tangent of theta, 2 times theta, I guess. Do this one here in green. So you got your formula right up here. So let me write that down. That is tangent 2 theta, and that's actually 2 times tangent of theta, and then 1 minus tangent squared theta. So that one's got a couple little details you got to be kind of careful on. So tangent is going to be the opposite over the adjacent there. You got the double negative, so it will be positive. And you start writing it out. So that'll be the positive, and then that'll be 7, and then over 24. And then we'll go 1 minus the other 7 over 24, just like that right there. Just all in the calculator. If you are trying to type in the fractions into the calculator, it's usually the alpha, the green button, and then y equals, and then you hit enter, and that'll get you a fraction there. So you can also just use the fractions like just using parentheses and divide bys right there. If you got kind of an old school calculator, just make sure on this denominator, if it doesn't have the fraction button, just throw an extra set of parentheses around the denominator so that the calculator forces it to do the 1 minus 7 over 24 first there. And then also, actually, you know what? I forgot something here. I got to square that fraction. So let me squeeze that in. Just like that right there. And then, yeah, just type that in the calculator. Apparently, I got 336 and then over 527. And then that'll be your answer there. So it's really straightforward once you have the formulas, and then it's just a lot of just plugging into the calculator. So that's really all we're going to do there on double angle identities, because honestly there's not a ton of variation to even really worry about there on those. You can use your double angle identities to, you know, go back to the old units that we've done. So like this is a solving problem. Solve this, you know, solve for theta right here on the interval from 0 to 2 pi. So what we're going to do, since we have this double angle right here, is we use our identity up here at the top, which is 2 sine and then cosine. So that's what I'm going to do there. I'm going to swap that out. 2 sine of theta, cosine of theta, and then drop down that minus sine of theta. Okay, and then from there, since you have a sine on both of those expressions right here, you're going to divide them both by sine. And if you divide by sine, you're going to be left with 2 times cosine of theta, and then minus 1 actually. And then since you have it equal to 0, now you can set your factors individually equal to 0. So as far as when it's sine equal to 0, that's the y value. That usually happens at 0, and then also pi. Okay, this next one here, when you go and solve this, this is 2 cosine theta equals positive 1, and then cosine of theta equals 1/2. Cosine's typically tied to your x value, so x values that are 1/2, I believe, would be pi over 3. And then the other one needs to be the positive version. I think that'll be positive 5 over 3. Positive 5 pi over 3, I guess I should say. Actually, I notice over here I need theta instead of x. But anyways, those are going to be your answers there. So it's just, you know, basically expanding it out just a little bit more. So yeah, really not too bad there on those. The ones that get a little bit more variation are going to actually be the part here of the second half here, the half angle identities here. So, you know, you got 1 for sine, 1 for cosine. There's actually 3 for tangent here. So what we're going to do here for tangent, I know on your formula chart it'll look like this here, but really these are these 2 examples right here. So you don't actually set things equal. It's this one here or this one, or this first variation, which honestly we don't really use the first variation a ton, maybe in very specific cases, but that's it here. So alright, so let's show you how to knock these out here. Find the exact value of cosine of 112.5. So like that's not actually something on the unit circle. So that's where these half angle identities are a little bit more powerful than the double angles. The double angles usually, like if you find something on a unit circle, the double angle, you know, if you double the number, it's usually that same number somewhere on the unit circle as well. But like we don't have cosine of 112 degrees. Or 112.5. So here is what we are going to do. We are going to see Well, first of all, we need to rewrite 112 as some type of angle, I guess, divided by 2 right there. That is equivalent to that. So actually to find that answer, really you actually go and double the 112. The 112.5 times 2 is 225, and then you're going to put that over 2. So these mathematically here are equivalent. And once you rewrite it here in this format, now we can go use that cosine formula up there at the top. Now notice here it does have this plus or minus symbol, and that's because we got to go and consider what quadrant this is at the very beginning. So we'll go and address that at the very, very end. You can really do it at the beginning if you want. And then it's 1 plus cosine of your angle theta, and then over 2. So instead of using now the 112.5, we're going to replace that there, theta, with a 112. Or I'm not, sorry, not the 112, the 225 right there. Because we actually have that angle on our unit circle. So we'll start going back and now doing that. That'll be 1 plus, and then the cosine of 225 degrees. That's on the unit circle. That's in quadrant 3, I believe, right there. And that should be a negative answer right there. That'll be negative root 2 over 2. So unfortunately, we're going to have a complex fraction. We're going to have a fraction inside of a fraction. And you got the square root, so you kind of got a lot of things going on here. So as far as simplifying this down there, here's a little strategy to get rid of the complex fraction. We're going to multiply this whole top numerator part by 2, which whatever you multiply by the top, you got to do by the bottom right there. So I'm going to multiply the top and bottom there, both by 2. That's going to distribute up there in the numerator. That'll come out to 2. When you distribute here to the second part, they divide by 2. The times 2 are going to cancel out, so that's actually going to become minus square root of 2, like that. And now you still have your radical going on. Down in the bottom, you'll get square root of 4. Okay, to take it a step further here, we are going to just rewrite this as separate square roots. So you can actually square root these individually. And then the square root of 4 is actually 2. I need my plus or minus here until the very end. Okay. And then I like to go back and figure out, and maybe I should have done this at the beginning, it doesn't really matter, I typically do it at the end, but I go and think about what quadrant, not what 225 is in, but where the 112 degrees is. And if you think back to that there, 112 is, it's a little bit bigger than 90, but not quite to the 180. It's somewhere around here. Alright, so since cosine is typically negative right there, your answer needs to be negative. So I'm going to actually take off that positive part right there and put the negative out in front. Okay, so you could technically do that there at the beginning. Maybe I'll do that here on the next one, so we don't have to worry about that so much there. But that is it right there. So they kind of simplified down weird a little bit, but that'll be your answer, and that'll be as simplified as we take it. Okay, so let's try out this next one here. Find the exact value of tangent of 7 pi over 12. So it's a little bit harder, in my opinion, when it's in terms of pi. So you want to eventually make this tangent of some type of theta and then over 2 right there. And kind of a good little rule of thumb here is to figure out what that is. You actually go and off to the side maybe double your angle. So you multiply by 2. And you could say, hey, that's 6, and then that reduces to 1. So that's 7 pi over 6. And that's actually what's going to go in this top part here. You're going to do 7 pi over 6, kind of like that, and then all over 2. So these here are mathematically equivalent things. So now the tangent formulas, like I said here, there's 2 variations that we use quite a bit. It's actually these quite frequently. You can use the one with the square root, but sometimes with the rationalized in the denominator, sometimes that gets a little bit messy there. So I like to use one of the first 2. Now, as far as like which one is better, it depends on like what angle you're dealing with here. It's like, so sometimes you can use the first one, sometimes you can use the second one. I will usually try this first one here, or I guess really it's the second, but I usually try that one there first. Because the second one, if you get a root in the bottom, you're going to have to rationalize the denominator, and that does kind of make the problem, I guess, a little bit, complicated. So more times than not, I'm going to try that second one there. So let me go ahead and show you what that's going to look like here. So the formula calls here for 1 minus cosine of theta. Instead of theta, we're going to do the 7 pi over 6. And then you're going to put down in the denominator, you're going to put sine of that 7 pi over 6 as well. So then if we go start looking here at our unit circle, cosine of 7 pi over 6 there, I believe that's going to be negative root 2, or I'm sorry, root 3 over 2. And you're going to have a double negative going on, so we'll eventually change that numerator to addition. And then down in the denominator, we'll do sine of 7 pi over 6 right there. And that is also going to be negative, so that'll be negative 1/2. Okay. And then kind of like on that previous example, if you got a complex fraction, you want to cancel out the denominators, you can actually do this little strategy here. You can multiply top and bottom here of the whole thing by 2. Do that here as well. So you'll do 2 times the 1, that'll get you 2. You got the double negative, so that'll be positive, and then the 2 in the denominator there and the 2 right there will cancel, so this will be square root of 3. And then you have 2 times the negative 1/2, so that'll be negative 1. And typically it's a bad idea to leave your answer in terms of, like, leaving a negative in the bottom of a fraction, so I'm going to change that to negative 2 and then minus square root of 3, and that'll be it. Okay. Now, typically with the tangent equations, if you're doing the second or third variation, you don't have to worry about the plus or minus, because when you do the cosine and sine, the signs will kind of take care of themselves. I guess if you do this first one, you do have to worry about the plus or minus, and then you do have to think about what quadrant the original angle lies in and if it's positive or negative there. So, if you go back here and think about this here, tangent is typically negative. That's going to be in quadrant 2. Tangent's typically negative in quadrant 2, and notice you got, kind of a negative answer there. So I'll be that there. Okay, let's try out one more here in terms of pi. So you got sine of 3 pi over 8. 3 pi over 8. We're going to go and write that times 2 off to the side. And this helps us figure out how to rewrite this here. So that would be 3 pi over 4. So we'll say this is the same thing as sine of 3 pi over 4 over 2. Once you have it set up in this formula, or this format, I guess, you can go and do your sine formula. Okay, let's do this time here. Let's think about what quadrant that lies in right there, and then determine if we need positive or negative at the beginning instead of putting plus or minus at the beginning here. So 3 pi over 8, the original angle would be here in quadrant 1 if you were to sketch that out there, so that should be positive. So we'll do the positive version, we'll do the square root. They call for 1 minus cosine. Then you're going to put your angle, 3 pi over 4, and then you're going to put that all over 2. Okay, let's go ahead and simplify from here. 1 and then cosine of 3 pi over 4, that should be root 2, I believe, over 2. Okay, and that's going to be, actually, that should be negative there, so that'll be a double negative eventually. That'll eventually change the addition. So double negative on that, and then you'll still put over 2. And this will kind of simplify like that 1 up there above, but we're going to do our little strategy of multiply the top and bottom here by 2. Okay, so that'll come out to square root, and that'll be 2 plus root 2. And then you'll have square root of 4 down in the denominator, and we will not leave that. We'll go ahead and simplify that. So that'll be 2 plus the square root of 2 plus root 2, and then all over regular 2. And then we already took care of our sign at the beginning, so we'll call that positive right there, and then we'll be good. So that'll be it there. Now the only other variation to these that you can do is kind of like on that first page there with the triangle where we draw it ourselves. We're going to do kind of the same idea, I guess, on this one here. So we're going to say sine of theta is 5 over 13. I think we're assuming top right quadrant on this one here, since they didn't really give us a whole lot of information. So let's go ahead and try it out here, sketch it out. It's another one of these triangles that comes out real nice, but sometimes you can get ones with radicals, so just simplest radical form if possible. Sine of theta, let's call that theta, so you'd put 5 to 13, that's your opposite and adjacent, opposite and hypotenuse, I'm sorry. And then your adjacent down there at the bottom will be the 12. And then now we're going to do cosine of pi over 2. Okay, and then we'll try that, I guess. So cosine is going to be the adjacent, that side right there. So since we already have theta, we're just going to write out the formula cosine. Theta over 2 is equal to, and then 1 plus cosine theta, and then all over 2 right there. So cosine of theta, we just can go look here at the picture here. Should be the adjacent over the hypotenuse, so that'll be 12 over 13. And then you're going to put that whole thing, I guess, over 2 right there. Okay. To start to kind of clean this thing up here, because you can't simplify, I'm going to multiply top and bottom here by 13. There's no denominator on this second fraction, so you don't have to worry about anything too weird here on this. So you'll get 13, and then actually plus 12 up there in the numerator. And then you're going to get 26 down there in the denominator. You start to simplify past that, that'll be root 25, and then over root 26. And it just so happened that root 25, that's a perfect square. So we can say that's 5 over root 26. And then we can rationalize by multiplying top and bottom by square root of 26. And that would be for cosine right there. Okay, to finish this out here for today, tangent of theta over 2. Let's write out that formula. Like I said, you got 3 variations. I usually stay away from the one with the radical. I kind of like that second one since you don't have 2 things in the denominator. It usually just makes simplifying it just a hair easier. So that calls for 1 minus cosine of theta and then over sine of theta. I have a lot of people put the actual fraction in for theta, but technically you don't put that there. You just put the fraction and you replace the entire cosine of theta. You replace it with the fraction there. So cosine is the adjacent over the hypotenuse again. So once again, instead of saying cosine of 12 over 13, just put the fraction 12 over 13. You actually replace the entire cosine. Sine was going to be the adjacent, the opposite over the hypotenuse, so 5 over 13. And then we're going to do our little strategy again of cleaning up complex fractions here. Multiply top and bottom by that denominator, multiply that fraction there by that denominator. Comes out to 13 minus 12 up there in the numerator. And the 13 and the 13 and down in there in the denominator will cancel, so that comes out to 5. So actually it comes all the way out to 1/5. And that'll be it here for today.